Hello and welcome back for another VMK in the game development series. We're still working with the GUI controls and adding in functionality piece by piece into all the different game states that the user will be able to navigate throughout. Now, we left off last time inside of the GUI state or game state options screen, and in there we rendered all the GUI controls on the screen so that the user has sliders and radio buttons and checkboxes to play around with, but all those controls currently don't do anything. And then, as a matter of fact, when you start up the program, you'll notice that there's a major flaw. Let's say that the user starts up their game and they go in here under options and say, oh, image quality is too high, let's set it down to be low, and maybe I want to run it at this resolution here. They hit back, they quit, they finish playing their game, whatever. Then they go and run the game again a second time. Now they go into the options and they notice, oh, I have to reset this image quality back down to low, and I have to reset the resolution over here. You notice that the state is not getting saved. It's not getting saved because, well, let me describe it this way. It is currently saved. If I go back into the options, you see it is low and the resolution is changed. But as soon as you quit the game and then restart it, everything gets reset back to the default values. And the default values currently are the values that have been hard-coded directly inside of our scene class's initialize function over here. You remember when we first create these controls, let me just find some here, like this radio button, we went and populated all the controls for it, but then down here we specify which of these options should we select. Well, we've selected to always select the first button, which is 800 by 600. But if the user changes this value and then resets the game or reloads the game, they want the value that they set saved over here. So we need to have an external file that will be the user's preferences or the user's configuration that they chose. Anytime that the game starts up, we will load in these preferences, pre-populate everything inside of the GUI or the game state, and then use those from then on. Anytime the user changes something, we need to update this file so that when the user quits and then restarts the game, those values that they last had are the current values inside of the game engine. Now, the way that all of this is going to work is through our UserSettings class. We already created this class many VMK ago, so it has structures that allow us to store many different things, like the speed of the mouse, whether what resolution the game is running under, things like that. So we're going to actually go into here, add in more parameters, because you'll see that in here under the options we need a parameter for resolution. We already have that. We need a new parameter for the viewing depth. We need a new parameter for the image quality. We need another parameter for the inversion of the mouse, and another parameter for the mouse sensitivity. So all of these have to get added into this class. But in addition to that, we need to be able to load in these values from a file. So we're going to need to create a file that will hold those parameters in there for us. So anytime we start up our game, we can load the file, pre-populate this class here, and then we'll use this class anytime we need to get the values or set the values of the specific controls. To start off, let's go into our game. Our entry point into our game is inside of WinMain. And over here, this is where we create the very first instance of UserSettings. We create him, and then from then on, we're just passing in a pointer to our game engine to use this UserSettings. So we're going to change the constructor here. The constructor we're going to update so that it actually loads a file in. If the file doesn't exist, it's going to pre-populate with fixed values. However, if the file does exist, it's going to load in the values and pre-populate its own internal values. Now, to keep things somewhat organized, what I'm going to do is inside of the game engine, this is where we're writing our code. We've created a directory here called build, and underneath here we have our debug folder, which is where everything gets dumped in when we compile. When we run, we're running from this directory. What we want to do is create a new folder here, and I'll call it save. And here is where we're going to be storing all of the saved games and all the preferences that the user chooses. Everything's going to go into this directory. We need to create this directory by hand. If we don't do this, then the code we're about to write will not do anything because it's not been written so that it creates a directory if one doesn't exist. It always assumes that the saved directory exists, which means when you wrap up your game to give to someone else, make sure that your installer or whatever you're giving to the other user will create this directory for them in the appropriate location. If this directory doesn't exist, none of the user settings will be saved to the hard drive, as well as save games inside of your game will not work because this directory won't exist. So make sure this directory exists before you do anything else. Back here, we're going to change the constructor so that we can pass in a file name, and we can do that like this. We're going to accept a character pointer to something called config file name, and we'll also need to go into this guy over here and add him in, and which means that back inside main CPP, whenever we create this guy, we need to specify a file name. Now, the file name could be anything you like, but I'm putting it inside of the save directory, so make sure that if you're doing the same thing, that directory exists. I'm going to call it, I don't know, config.ini. Alright, so this will say to the constructor of user settings, please load in config.ini located in the save directory. The slash here does matter. Don't use this slash here because that's an escape key inside C++. Use the /. Okay, so let's go into our constructor now, over here. And we need to do a few things here. First, we should create some variables to hold all the different settings which we're going to be saving inside of this file, so that when we do load in the file, we'll have somewhere to put them. We're going to need a parameter that is going to store the mouse speed. We have that, and we need a parameter for telling us whether the mouse is inverted or not. So we're going to add this boolean. We already have parameters up here to indicate the resolution of our screen. So by default, I think it's 800 by 600. But we do need to add two more parameters, one for the viewing depth and one for the filter quality. So we're going to add these two down here. Inside of our constructor now, we need to initialize the default values for those parameters we just added. I like to have my mouse inverted, so I'm going to set this guy up to be true. You can make it false if you like. And down here, let's add in the viewing depth. We'll default it to 1000. And the filter quality, we'll set it up to be filter quality 3 as the default. Okay, let's compile this, make sure we didn't miss anything here. Filter quality is included in a header file, texture.h. So we need to reorganize this so that we can have access to the filter quality within user settings. The easiest way to do that would be just to take this guy and put him inside core.h, since core.h is something that texture.h will use and user settings will have access to as well. I think it's already included in here, isn't it? Yeah, core.h. So let's just go into here and add them in. Let's just put them in at the bottom. Okay, let's go and compile him. Alright, that's all that was missing, I guess. Now, what we've done is we've passed in a parameter here. We've set up the default values, but now we should go in and see if this file exists, because it may not exist on the hard drive, even though you specify it. However, if it does exist, we want to open it and then load in the values that are in that file. To load in the file, from this file name that was specified here, there's a number of ways to load files in C++. I'm not sure if I've shown you this method or not, but if not, well, here's another way of doing it. Again, you can stick to one way of loading in files, but I'm trying to show you many different ways of doing similar functions so that if you do see something in someone else's code, you'll be able to identify it. By using the standard template library, you can use fstream to create a file stream directly in and out of a file. I'm going to create this std fstream called config file, and we call the open parameter on config file. You specify the file name you want to open, and then you specify whether you want to read in or output data to this file. I want to read in, so I'm specifying here std fstream in. You should check to make sure that this file is open before you do any work. If it's not open, then that means that we couldn't open this file here, which most likely means that the file doesn't exist on the hard drive. I'm going to create a couple of variables here, which I'm going to use to store the values that are inside of this file. So we have the resolution width and height, the depth, the filter quality, inversion of the mouse, and mouse sensitivity. Now, notice that inversion of the mouse, which is a boolean for us, is really an integer here. There isn't a way to save a boolean value into a file. So instead, I'm saving either a 0 or a 1 to indicate true or false, or I should say false or true, respectively. So 0 is false, 1 is true. Everything else should be pretty straightforward in terms of the values that are getting returned here. To get the values from the file, we use the greater than sign here on the config file fstream, and what this will do is it will take the current file pointer inside of this fstream, and whatever's there it's going to put into our variable located over here. So first thing inside of the file is going to be the width, then the height, then the depth, then the filter quality, inversion of the mouse, and then mouse sensitivity. That's the order that is expected to be inside of the file. Next, we can close the file because we're not going to need it open anymore for us, so we close it automatically. And then we need to do some checking to make sure that all these values are actually valid. Because it could be that this file here is on the hard drive, however the values that are inside of the file are invalid. And this can sometimes happen if, for instance, you create a game that has a certain file specification, but then you incorporate a patch. The patch forces you to change maybe how the configuration file is structured. Therefore, when you load it in, next time you load it in, it may not have the values you're expecting to have in there. So to prevent your program from crashing, you should always check to make sure that the values you're expecting are the values that you actually have. Now, with what I have here, all of these are numbers, so I can just check their ranges to make sure that they're within specific value bounds. I know that the resolution, we have three settings, 800 by 600, so that's this one here, or it can be 1024 by 768, or it can be 1280 by 1024. So if it's one of these, that's a valid value, so what I'm going to do is I'm going to take the width, take the height, and save those into our member variable, which is what's used from now on. Next, we have the depth. The depth has to be less than or equal to 2000, and it also has to be greater than or equal to 500. That's the valid value range for our slider. So if it's outside of this range, we're not going to touch whatever's inside here. If it's valid, we're going to save it inside of our member variable. For filter quality, it has to be either 1, 2, 3, or 4, so we check to make sure it's one of those values, and then we cast it to be a filter quality parameter, and then we save that into our member variables. For the mouse invert, it can only be 0 or 1, so if it's either of these, we're going to take the mouse invert value. If it's greater than 0.5, we're going to save true into here, or if it's not greater than 0.5, we're going to save false. On the community forum, one member asked me, why is it that I do this kind of if statement comparison? I do this specifically for you guys so that you can see if this is true, what is it that gets saved here? But you can actually simplify this and rewrite it to be like so. This will give you the exact same output as this guy over here does. I only write it out this way so it's a little bit more clear. But if you want to simplify your code, feel free. Just don't bother writing this part out here, because the first section, which is true, is always going to return true, and the second section, which is false, is always going to return false. So anyway, moving on. Last parameter is mouse sensitivity. It has to be between this range and that range, because that's what the slider specifications say. So if it is between here, we're going to just take that value and save it inside of our member variable. Now, there's one other thing we need to do here, and I forgot to mention it earlier. Inside of user settings, this guy is going to be responsible for saving our config.ini file. However, we don't know where to save that file because we're currently not saving a file name that will tell us where to save it. So what we can do is we can take this parameter that gets passed into our constructor, save it internally as a member variable, and then anytime we need to save these values here, we can just use that internal parameter. So to do that, let's go into UserSettings .h, and down here create another variable. Actually, I'm going to put it at the top because it's sort of the most important thing if we're going to be saving something. So I'm defining here m_p_sed file name is going to be a pointer to a character array. We don't know how big this guy is because it really depends on what gets passed into the constructor over here. So because of that, we're going to need to do some manual cleanup on the destructor over here, which we can just call save delete array on our member variable. And over here, after we've finished loading in all the values and things like that, we can save the file name that gets passed into our member variable. We first figure out how long or how many characters are inside of the string that contains the file name and path. We add one to have a null terminated string. We call the new operator on our own member variable. If he succeeds, we'll just call snprintf, and we're passing in the variable where we want to save all the information, the amount of data we want to save, and then the data that we're saving is scconfig file name. So that's going to save our file name for us, and we're also going to have to create a function to actually save everything to a file, but we're not worrying about that just yet. So let's compile this now. And okay, everything looks good. If we build, I think everything should be okay. Okay, everything seems to be working just fine. So we have our values now stored inside of user settings. We should now create some functions so that we can extract these values because all of them are private, so we need some accessor functions to be able to get at those parameters. So let's start adding some functions into here. We've added getViewDepth, which returns a member variable. We have setViewDepth, which sets the variable. We have getFilterQuality and also setFilterQuality. We have getMouse or getInvertMouseY and setInvertMouseY. And we have getMouseSensitivity and setMouseSensitivity. Now you can go in here and make sure that when you're setting, the value here is actually valid. That would be probably a good thing to do, just to make sure that your code is not going to break on you because someone is trying to set something that is beyond the range of your sliders. I forgot to do this when I first wrote this code, so let's go in and just quickly add that as well. So if the view depth that gets passed into here is less than 2000 and it's greater than or equal to 500, then we're going to save the value inside of our member variable. If it's not between that range, we're not going to save it. For filter quality, we need to do something similar. Let's take this parameter here, copy it over. So if the filter quality value is greater than or equal to 1 and it's less than or equal to 4. Now, filter quality is a enumeration, so you shouldn't be comparing with 1. You should actually be comparing with the filter quality values. Let's just go into here and steal them. So filter quality 1 and then filter quality 4. Okay, and we have set mouse invert, you can only set it to be true or false, so there is no checking needed here. But mouse sensitivity, we can specify invalid ranges, so let's go into here and make sure that whatever gets passed in is valid. Okay, let's go and build this, make sure we didn't break anything. Oh, looks like I spoke too soon because we did break something. I'm missing some parentheses here. Okay, so we now have ways to get at all those variables we just finished adding in. Now we need to start tying in these values inside of UserSettings with where they're supposed to be used inside of the game engine. Let's start off with the first one here. We have get view depth. The view depth is important inside of GameOGL set projection matrix. When we set up the GL perspective, we have our minimum parameter and our maximum parameter. So this guy here is responsible for telling us how far can we see inside of our perspective model view matrix. So instead of hard coding it to be 1000 now, we're going to instead call UserSettings get view depth. So anytime we update this guy, our model view matrix will use his correct updated value. The other place that we need to use this getViewDepth function is when we first create our slider inside of our options menu. And that is located inside of scene initialize. So we need to find pSlider. Is he the one? Yep. Oh, let me just fix that. Here he is. We're going to create our slider for our depth, and here we've hard-coded that the initial value is 1000. So let's replace him with UserSettings get view depth. Alright, so that should handle the first parameter. Let's move on to the next guy. We have get filter quality. Well, we know we need to update the scenes slider here for the filter quality, so let's locate that guy. Slider for the depth. This is slider for the quality. So in here we've hard-coded to have the default value of 4. Now let's use the UserSettings get filter quality value, and this guy's going to return to us a filter quality enumeration, so we're just going to cast it to be a floating point number so that it works with our slider appropriately. Now the other place that we need to use this is anytime we load in a texture, because when we're loading in a texture we need to specify what is the quality of this texture. So the easiest way to find that would be to do a search for a texture. And that brings up quite a few. Should try to narrow this down as much as possible. Let's do a search for texture and then an open bracket. Well, that's a little bit better. Still quite a few hits here. Let's do search for a texture with an open bracket, but we need to match the case and match the whole word. How many does that find for us? That finds 11. That's a little bit better. Okay. Looks like whenever we do create textures, we're most likely going to be passing in an eye quality factor, or we've passed in a variable here. So, well, I don't think there's a real easy way to do this, but I think this should handle pretty much all the cases. Okay, so we're inside of scene parse line, and it looks like we're parsing probably the cob file, and if we found a texture, we want to create a texture using the eye quality factor that was loaded in from the file. So we don't want to overwrite that one. That one's probably safe to leave. Let's see what this one here does. This one is loading in a texture, but we have a F quality factor of 4 specified. Well, let's go and replace him so that we're always using whatever our PUserSettings is set up to be using. And as a matter of fact, let's just do a search for F quality. This will ensure that we're going to find all of the textures that are using a hard-coded quality factor. This guy didn't find anything. That's odd. Let's do case match for F quality. Okay, 17. Here we're hard-coding that the default value is going to be 3. That's fine. Here's all the quality factors for core. We don't want to change any of those. This is for setting up the filter, so we don't want to change that either. Here's the first one that we're creating a new texture, and we're specifying quality factor 4. This is for the text, so most likely the text we do want to have the highest quality. Let's not change that. Next guy is text as well, and let's change that. Texture image for our GUIs, we most likely want highest quality there, so let's leave that as 4 as well. What else do we got here? Cases, and that's it. That's odd. There should be another spot where we want to replace the texture quality, and that would be back inside the Caligari loader. Where is he? He's under Object, inside Caligari Poly H, or is it Shader Box? Maybe it's Material. Or no, it's not in there. It's inside of our scene. We have Load Caligari File. Here it is. Let's just do a quick scroll through here to see where the textures are being created, because those are the ones we want to override using the specific texture quality format that we're using. So here it is, load texture. Oh, we've already changed this guy. So that's the Caligari file one. That one's fine. The other one, which was inside of parse line, let's just check to see if we updated him. Cylinder, grid, material, texture transform, texture. Yeah, this one we don't want to change because whatever is inside the LVL file is going to specify the quality factor here, and then by default, if they didn't specify a parameter, we want to use a default value. Now, well, here, instead of hard coding the default value as 4, we can hard code it so that the default value is whatever the PUserSettings quality factor is. Alright, those should be all the changes we need to make for the quality factor parameter. Now let's move on to the next parameter we added, which was getInvertMouse. Okay, getInvertMouse should be initialized inside of our scene. He was located inside of here somewhere, near the bottom, I think. Is this it? Here, button mouse invert. Yep. So here we can specify whether the button is turned on or off, and we can set the set press state to be whatever the PUserSettings getInvertMouse Y value is currently set. Okay, next up is the getMouse sensitivity. And that again, we need to go back into our scene and under initialize, and in here, near the bottom somewhere, I'm sure. Oh, went too far. Back inside initialize, we need to find where we had the sensitivity slider. Slider for quality, slider for mouse sensitivity. So if we scroll across here, instead of hard coding it here to this value, we're just going to use MPUserSettings getMouse sensitivity. Alright, let's build this, see what happens. Have a warning message here. Oh, We need to convert this to an integer rather than a floating point number, and we forgot a semicolon at the end there. Alright, so that all seems to be working fine. Now, if we run it, we shouldn't see any difference if we go into the options, because if we go and change these values around here, we hit back, we hit quit, and then restart, notice that none of the values have kept. They're not keeping because we're currently not saving the configuration ini file to the hard drive when we quit. We need to still specify we want to do that. And after that, we still need to add in the functionality so that when the sliders are changed, we actually go into PUserSettings and update the values in here as well, so that when we do save the file, we'll have the newly changed values to be saved to the hard drive. Okay, so the first thing is deciding when we want to save our PUserSettings data. We'll do that whenever we're cleaning up our scene. So if we go under here, we should have a clear all function. Or sorry, we don't want to be inside of the scene. We want to be inside of GameEngine. So when the GameEngine is closing up and cleaning up, we have a cleanup function. And inside of here, what we're going to do is we're going to call m_p_userSettings. And here we're going to call a function that's going to be inside of UserSettings that will save our file. But we haven't written it yet, so let's first go and write that function. Inside of here, I'll just put it here at the bottom. Actually, no, I'll put it at the top just so we don't lose it with all the other stuff. We have constructor, destructor, set pointers, and then we'll have save file. Save file is only ever going to get called once whenever GameOGL is going to get cleaned up. So what I'm going to do is implement it inside of the CPP file rather than the .h file, which means that it's not going to be in line. But that's okay. So down here, let's add the following. We're going to call this function whenever we want to save the values that the config.ini file contains. So we're going to check to see if we have a file name, and I'm going to create this other variable here called m_b_changed. This guy is going to keep track of when we change values that are inside of this file. So for instance, when you first load up the config file, you would load in all these values here into memory. However, if the user doesn't change anything, at the very end when we call save file, there's no need to actually resave the same values back to this file. So that's what this parameter is going to do. It's going to tell us whether we should save it or not. And this parameter is going to get changed anytime we update any of these 6 parameters. So I'll implement this guy in a second, but let's just take a look here inside of the save file function. We're going to use the same method that we used to load in the config file by using this fstream. We open up the file name that is specified here in our member variable, and this time we're specifying that we want to use the out command here. We check to see if the file was opened successfully. If it was, then we're taking each of these values, which are our member variables, and outputting it directly into our file stream, which is now this config.ini file. At the end of every number or value that gets output to the file, I'm adding in a carriage return and line feed so that the next value is on the next line. So here we go, we have resolution width, resolution height, depth, filter quality. Inversion of the mouse is a Boolean value, but we can only save numbers or letters to the file, so I'm going to change this Boolean to a 1 if it's true and a 0 if it's false. And then lastly, we have the mouse speed, which is the mouse sensitivity. After saving all of that, we're going to close the file stream, and then we're done. Now, this is the function that we want to call inside of GameOGL. So right in here, we're going to call save file. Okay, now let's go back into user settings here and create this variable. Just at the bottom. Let's see. Let's put it right here. we're going to initialize this guy such that he is by default false, meaning that nothing has changed. And we'll put that inside of the constructor. And anytime we change any of those 6 values, we need to update this guy to be true. So let's go and do that. Okay, the first thing was the resolution. How was it that we were saving the resolution? Let's go back into our main and just take a look here. The resolution is initialized inside of the constructor, and then we just pull it out using the getResolution, but we don't have a setResolution function. That's going to be problematic because our radio buttons allow you to change the resolution, which means we're going to have to add in a function into UserSettings here to allow us to change the resolution. So before we go any further, let's go and do that. So here we go. Set resolution, we're going to specify the width and the height. And we're going to check to make sure that the width and the height parameters are valid. There's only 3 fixed values that you can currently set the resolution to. There's 800 by 600, 1024 by 768, and 1280 by 1024. So if the selections here are such that it's one of these cases, then we're going to change our member variable here to be true, and then we're going to take those values and save them inside of our member variable. If these 2 values, the width and the height, are not one of these sets, then we're just going to skip over and not do anything. Let's take this and let's see what else we had here. Set window size, we don't worry about that. Set game state, we don't worry about that. Set mouse offset, we don't worry about that. Left mouse button, okay, here we go. We have set view depth. So whenever we're changing the viewing depth, we need to make sure we add this parameter into here. Filter quality, do the same thing. Setting the mouse inversion, we'll need to set that up as well. And I think there's one more, the mouse sensitivity, right here. Okay, so I think that should be it for the changes inside of user settings. Let's compile this, make sure everything's okay, and then we can go back into our game OpenGL, make sure we can build him as well. He's fine. I think that only leaves us to have to go into our scene class and make the changes such that whenever the sliders are updated, we go and change the values inside of the user settings. To do that, we're going to need to go into the function called, what was it, something hotspot, GUI check hotspots. So in here, this is where we're making decisions based on what controls are being pressed. So the first thing, let's handle the case when the user is changing the resolution. The resolution is controlled not by a GUI button, but rather by a GUI radio group. So we're going to need to make a new if statement down here. So if this control that's being selected is a radio button and the mouse button is being pressed, then we check to see whether we're pressing the 800 by 600, 1024 by 768, or 1280 by 1024 radio button. Depending on which one of these is being pressed, we're then calling set resolution on user settings and then passing in the values of the new resolution that we want to be setting. So that should take care of the width and the height. We next have to take care of the depth parameter. The depth and actually the filter quality and mouse sensitivity, they'll all work similarly. They're not part of the GUI buttons and they're not part of the GUI radios. So again, we need to make a new grouping down here for the GUI sliders. So if we know we're working with a slider, we're going to take the GUI control type, check to see if it is a slider. If it is, we're going to extract the slider control out of the control list here into pSlider. Then, using the ID number, we're going to check to see if we're using the depth slider, the filter quality, or the mouse sensitivity. Depending on which one it is, we're going to call the appropriate function inside of UserSettings. We're going to set the depth if we're using the depth slider, and to get the value that the slider is currently at, we just call pSlider_getValue. This will return to us the current value of the slider. So this is going to return to us a number which we can then directly push into our setViewDepth function. Same thing goes with the filter quality. However, to set the filter quality, we need to pass in a filter quality data type. So we take the getValue function, it's going to return to us a floating point number, which we then cast it to be an integer, and then all of that gets cast to be a filter quality enumeration. And then that gets passed into our setFilterQuality function. Lastly, we have the mouse sensitivity, which we can just get the value from the slider and then pass it directly into setMouseSensitivity. So let's go and build this. And oh, there seems to be a mistake in here somewhere. Oh, pSlider is undefined. We just need to go up to the top here and add it in. Okay. So if we build this, we should have a program that can get us up and running now. Alright, so we have some options. We have resolution settings here. We have a viewing depth, image quality, and mouse inversion and mouse sensitivity. Well, let's try this out. What's the easiest way to demonstrate this? You'll notice that the resolution, let's play around with that. I'm going to set it to be 1024 by 768. Notice that when I hit back, nothing appears to change. And when we actually start playing the game, we can run around in this world, but the resolution in the window is still 800 by 600. Let's quit this and rerun our program. Notice that now that the resolution has been changed, our menu items are in a different location and the window is much, much bigger. It's actually now taking the effects of the new resolution. One thing that didn't happen though, notice that the buttons here were not initialized to what they should have been. They were still initialized to the original defaults, even though that's not what the current value is. So we're going to have to go back and fix that bug. Viewing depth, well, there isn't a good way for me to demonstrate that because our world isn't very big. But if you had a very large world with many different items in it, what you can do is slide this down to the very near side, play your game, and you'll see that you can only see a certain distance away. Then slide this up to the far side, rerun your game, and you'll now be able to see more stuff in the world. I can't really demonstrate that because I only have a flat rectangle on the ground, which isn't all that detailed anyway. So we'll forget this. And image quality, you can play around with that and you can see the effect of it. If you go back to the previous VMKs, you can see the differences between boxes. I think I showed you of what happens when you load an image in low quality as opposed to high quality. Mouse inversion is easy to demonstrate. Right now the mouse is inverted, so if we go back into here, actually, okay, resolution is set back to 800 by 600, so next time I restart the program it should be a smaller window. Alright, right now mouse is inverted, so if I press forward on my mouse I'm pitching downward. That's the way that I like to have my application run. Let's go and change that mouse inversion under options, mouse inversion. Now when I run the program, if I push forward on the mouse, it's still pitching downward. So the mouse inversion is not taking effect yet. We're going to have to fix that bug. What was the other option in there? Oh, mouse sensitivity. Okay, let's crank up the mouse sensitivity, see if this parameter is being used by our game engine. Go into the game, and now when I'm moving the mouse around, it definitely feels a lot more sensitive to me. It's moving a lot faster on the screen. So mouse sensitivity seems to be working fine, but the other parameters are not. So let's go in and make those fixes. Let's first fix the radio buttons that designate the resolution. If we go into our scenes initialize function, when we create the group for the resolution, at the very bottom we designate which is our default button. Here it is here. And right now, by default, we're always setting it to be 800 by 600. So what we can do here is replace this code with the following. We're going to get the resolution width from UserSettings, and if it's 1024, then we know that we want to select the second button. If it's 1280, we want to select the third button, and if it's neither of these, then we're going to select 800 by 600, so we're going to set up the default to be equal to 1 here. Now let's build this and run it, and we should see that the resolution is now being selected correctly. So here we go into options. I'm going to change it to be 1024 by 768. I'll quit, and now this time when I run it and I go into the options, notice that 1024 by 768 is actually selected. So that's working fine. Let's just change it back to 800 by 600. To fix the mouse inversion, it's a little bit more work. If we go and take a look at how the mouse inversion stuff works, we can see that inside of player, this is the class that we're using to change the way that the player's head is pointing, and he's deriving from a class called camera. And camera, if we go into here, you'll see has a variable called m_mouseLookState. And this guy is responsible for telling us, this guy here, whether we're normal or inverted. Now if we go and do a search inside of our code for when this variable is being used, we'll see that there's only a few spots. There's these ones here, which is used whenever we're actually pitching upward or pitching downward. So here's where the variable is being used. And the only place we set it is currently inside of the constructor for player. And by default, we're setting it to invert. So what we need to do is create a new function inside of player that will allow us to change this mouse look state depending on what the GUI checkbox is selected to. So first thing we should do is go back inside the initialize function for scene. And if we scroll down to where we create that checkbox for the mouse inversion, it should be down here somewhere. Slider, another slider, menu control items. Okay, it should be in here. Okay, here's mouse invert Y. That's the text, and then we have our button right here. And down here, this is where we decide whether we want to set the mouse inversion to be on or off. And the setting is actually saved inside UserSettings like everything else is. So what we're going to do right here is whenever we initialize the checkbox here for the inversion of the mouse, we're also going to set the actual state of our player. So we're going to need to write this function here called setMouseY, and we're going to pass in the state of the current mouse inversion from UserSettings into that function. So let's go into player and add that new functionality. Inside of the player.cpp, I'm just going to add it right at the very bottom here. So if we're passing in true to be inverted, then we're going to take the mouse look state and set it equal to be invert. Otherwise, we're going to set it up to be normal. So that initializes it, but we also need to change one other spot, and that is inside of scene. And we'll just copy this code, and what we're going to be changing is inside of the function, what was it called? Check GUI hotspots. So in here, this is where we know that we're going to be pressing a button, and the button we're going to be pressing is the inversion button, which I don't see in here right now. So let's go and create a new case here. And what we're going to do is the following. So if the options button mouse invert is pressed, then we take the player class and we set the mouse Y equal to whatever the button state is. If it's pressed, we're going to set it to true. If it's not pressed, we're going to set it to false. We also update the PUserSettings value by calling setInvertMouse and passing in that same value from pButton. So now let's go and compile this and give this a try. Right now we have mouse inversion turned on. So if we go back into here, if I move forward on the mouse, you notice that I'm pitching downward. Okay, let's quit and turn mouse inversion off. Now if I move forward, I should be moving upward or pitching upward, which I am. So there we go, we have mouse inversion correctly enabled now. Let's just go back in here. I know sensitivity is really slow, so I'm just going to crank it up to be about halfway. Alright, so that's about it. Oh, I might as well throw in one other thing. I know this video is getting a little bit long. I just want to clean up everything inside of this options screen. The one last thing I wanted to show you how to do is, let's say we're changing the resolution here to be 1024 by 768. Notice that everything right now is centered on the screen. But as soon as I rerun the program, it's no longer recentered. And the reason for this is because the coordinates that we're using to place all of our controls are always with respect to the bottom left-hand corner. And because of that, when we increase the resolution size of our window, there's nothing over here, so everything is sort of skewed to the bottom left-hand corner. We can fix this by either creating dynamic coordinate systems for each of our controls, or by creating an offset that will center all of our items but maintain their actual spacing just the same as they are right now. So I'm going to show you how to do the second option because it's a little bit easier to do and it won't take very long to implement. So let's go back here and actually let's return this back to 800 by 600. First thing we're going to do is we're going to add a new parameter to our GUI control. And he's located inside of the object lib. Actually, let me close these guys off just to clean up the workspace a little. So inside GUI control, we're going to add the following parameter. He's going to be a static vertex 2, and I called it here res offset. So this is going to be the resolution offset that will allow us to center all the GUI controls in the center of the screen. We already know that everything is centered accordingly when we have 800 by 600 resolution. So all we need to do is figure out the offset whenever we change to all the other different resolutions. Because this guy's static, all the GUI controls that are going to inherit from GUI class, which are all of them, are going to use the same variable, and we only need one offset value, but then all the controls will need to be offset by whatever the value here that we're going to set. Because this guy is defined as being static, we need to go and initialize some memory for him, and I'll do that right at the very top of scene. Because this is where we have all of our other static members. So here I specify that this is a vertex 2 type belonging to GUI control, and there's the name of it. By default, I'm going to set this up to be equal to 0, 0. So there is no offset. To keep things clean, I'm going to go inside of scene.h and create a new function which we'll use whenever we need to update the offset value. And I'll put it down here underneath delete all GUI. So I call it GUI update resolution offset, and let's go implement him underneath delete all GUI. So here it is. Anytime we call this function, we're going to check to see what is the current resolution saved inside of PUserSettings. If it's 800 by 600, we'll go down here into this case, and we're going to reset the resolution offset value to be 0, 0. However, if it's 1024 by 768, then we're going to change the offset value to be 112 by 84. If it's 1280 by 1024, then the offset is going to be 240 by 212. If you're wondering where I'm getting these numbers from, they're not too hard to calculate. what I'm doing is I'm figuring out what is the difference between 800 by 600 and these other resolutions. If we have 1024 by 768 resolution, then the difference between that resolution and 800 by 600 is 2 times this value. And the reason why it's 2 times is because I want to create a buffer on both the left side and the right side of my screen. So in essence, this offset tells me exactly how much I should move all my controls so that everything will still be centered on the screen even though I'm using a different resolution. And the same thing goes with this one here. If I take 1280, subtract 800 from it, and then divide that number by 2, I'm going to get 240. And then if I take 1024, subtract 600 from it, and divide that by 2, you'll get 212. So that's where I got all these numbers here. Now, the only thing left to do is to actually use this V2 resolution offset inside of all of our GUI controls. So let's start off with our GUI button. Inside of our render function, we created this structure here with the texture coordinates and the vertex coordinates. What we want to do is we want to offset the vertex coordinates. So in here, we're going to add the X value of the resolution offset to each of these parameters, like so. And then we need to do the same thing for the Y values. Like so. So that should fix all the GUI buttons. Now let's move on to the next GUI control. Looking in our list here, we have GUI control, and inside here we need to update isOverHotspot. This is the guy that's going to be using our coordinate system to figure out whether our cursor is over top of the current hotspot. Well, the hotspot is going to move on us depending on the resolution. So in here we're going to need to create an offset just by adding the resolution offset here, as well as by adding it over here. We also need to offset the Y direction. So let's update that and list over here as well. Okay, moving on to the next control, we have GUI radio. I don't think I need to update anything in here because GUI radio actually uses everything that belongs to GUI button. So he's going to automatically update himself, so we can skip over him. Next guy is GUI slider. We also have a check hotspot function inside a GUI slider, which depends on the coordinate system. Here we can see we're in the horizontal direction, we're taking the mouse and we're subtracting the X and the offset, so we need to add the subtraction of the resolution offset, and we also need to do that for this case as well, but here we're going to change this to FY. When we go and render our slider, we also have to incorporate the offset, so over here add the following, and for the Y coordinate we also need to add the offset, like so. Now, because our slider has 3 sections to it, we need to add this offset to all 3 sections. So the next one down here, we have this guy, and we need to add it to the Y as well. And finally the last one down here. And to the X as well. Okay. The next control that we have is GUI text, and when we render him, we're going to have to apply the offset. So in here, we're going to add the X coordinate offset, and in here we're going to add the Y coordinate. And I think that's it. So let's compile this, make sure everything still builds correctly, and let's give it a run. So under 800 by 600, everything should still remain at the same location where it was before, because our offset is 0, 0. However, when we change the resolution to 1024 by 768 now, we can quit and rerun the application, and let's take a look here. Oh, nothing got updated because we forgot to call that new function we just created inside of scene. We never called GUI update resolution offset. Let's go and call him right in the constructor of scene. So could call it anywhere. Let's just do it right here at the top. So we'll set up the GUI position offset to use for the selected resolution. Let's rebuild this and give it a try. Oh, we got a problem here. Let's break out of this and see what's going on. Back inside of scene, let's just take a look in here quickly. Oh, we're using m_p user settings, but we haven't actually initialized it yet till down here. So we're going to have to call this function after we've initialized p user settings. So let's just add it to the bottom. Let's give this a try. Yay! Okay, so 1024 by 768 now resolution, and notice that the controls are now centered on the screen. If I select options, all of these guys are now centered on the screen as well, and you can now actually see the back button, which was being cut off by the video because it was underneath the border of the resolution that I'm recording under. So because everything's getting offset for us automatically, everything maintains the same spacing, and it sort of looks the way it should. It doesn't look like it's offset sort of in the bottom left-hand corner and there's a lot of white space around here. Instead, we've moved everything to the very center of the resolution that we're choosing, and everything is moving accordingly. We have now officially finished implementing the game state options screen. Come back for the next video where we're going to tackle the game state loading screen. We've already implemented the entry point and the exit point, but right now this guy doesn't do anything. So in the next video, I'm going to show you what this guy's responsible for doing and how we're actually going to achieve to do what he needs to do.